Welcome to Omniclean. It's a pleasure to introduce the team: Samin, Jason, Burke, Alinka, Donald, Shabri, and Sharanya. The scope of the project was to deliver an application which would enable customers to access high-quality cleaning services through an interactive and user-friendly platform. The prototype of the web-based cleaning service platform should offer people the possibility to easily access services that fits their needs and schedules. Since we planned to follow the agile methodology, we organized ourselves to work collaboratively and iteratively, setting ambitious targets according to the flow diagram shown. This highlights the linear organization of tasks. However, this flow was flexible as we frequently revisited various stages throughout the duration of the project. As shown, industry benchmarking was conducted at the start of the project to gain an insight into the cleaning industry and our competitors before listing functional and non-functional requirements. This diagram highlights some of the most salient functional and non-functional requirements. In terms of functional requirements, this includes advertising services offered, showing areas that are covered, and displaying how to contact the company. For non-functional requirements, this includes the user interface running on an internet browser. The system shall support popular browsers and should be written in accordance with standard Java conventions. The domain model shown here was created in response to the requirements, visualizing relationships between key entities in the system. Three types of relationships can be seen in this model, including aggregation, composition, and generalization, with three main actors: the administrator, the cleaner, and the customer, but the common denominator between all three being the cleaning job. The domain model was pivotal in developing a coherent use case analysis. Shown here are 15 use cases which were created to explore the various ways actors can interact with the Omniclean service. Main actors include the customer, the cleaner, and the administrator. Shown here is the Omniclean case diagram, which illustrates the key use cases such as book cleaner by the customer, login from the customer, accept or decline booking from the cleaner, add or remove cleaner by the administrator, and so on. The traceability matrix shown here maps use cases to the functional requirements, acting as a corroboration that all necessary connections are made between use cases and their corresponding requirements. Also part of the object-oriented analysis are the sequence and activity diagrams, which demonstrate a set of runtime scenarios regarding the various use cases, as well as incidents created by external actors. As shown, the customer visits the create account page, creates an account, goes through form validation, the data is saved to the database, a new customer is saved, the confirmation is displayed, and an email is sent to the customer. This sequence diagram illustrates the sequential flow for a customer who wishes to book a cleaner. As shown here, the user visits the portal homepage, logs in, submits job details, selects a cleaner service, books the cleaner, sends payment, opens the secure login, confirms payment, and creates the job. The job is then saved to the database. The sequence diagram reflects the stages involved in declining a booking. As shown, in order to decline a booking, a cleaner logs in, views upcoming bookings, and decides to decline a booking, listing their reason. This is submitted and another cleaner is reassigned to the job, and a job is added to a new cleaner. After passing various other stages between the admin, database, notification, and customer, the booking is successfully declined. The sequence diagram shown here is for when a customer wishes to review a cleaner. After logging in and viewing their booking history, a customer is able to write some feedback. Once this feedback is approved by the admin, it is sent to the database. This sequence diagram for creating a cleaner account involves clicking on the career tab, the login page, and a sequence of activities controlled by the admin to create a new cleaner account. Activity diagrams shown over the following slides were created, allowing via an iterative process a complete realization of the use cases. This ensured that each object had the correct associative methods, that each use case was correct, and allowing to progress to the process of object-oriented design. The first activity diagram shown here is for booking a cleaner. The main steps for a customer include login, searching for a postcode, booking a cleaner service, and making a payment. The create cleaner account activity diagram centers around a job request notification, the admin adding the cleaner and inserting this query into the database. The accept or decline booking activity diagram centers around login, cleaner confirming a booking, the booking being accepted, the confirmation being displayed, and an email being sent to the customer. The review cleaner activity diagram centers around a customer receiving an email prompting them to leave feedback. The customer then leaves feedback, the admin approves the feedback, and this is reflected on the Omniclean website. As part of the object-oriented analysis, the analysis class diagram highlights the different types of objects in the Omniclean system and their interrelationships, and illustrates all the main classes that form the system. The diagram shows the boundary classes such as the data boundary class and the boundary class, which interface with the database and web interface respectively. It also depicts entity classes such as the customer, the cleaner, and the job classes to show the objects that represent the system data, as well as highlighting the controller which acts as a mediator between the entities and boundaries. It is worth noting that this is a preliminary diagram of the design and does not yet specify all the key relationships between various classes, as well as attributes and operations which are depicted in the design class diagram. The design class diagram builds on the analysis class diagram by adding a further layer of precision and complexity. This diagram is essential to facilitate the translation of various aforementioned parts of the project into code. The class description diagram shown here provides a summary of the design class diagram and serves to eliminate ambiguity regarding the meaning of each class. The web page structure diagram shown here highlights the relationship between pages of the website and has been developed as a progression from code to creating a user-friendly interface that is simple for actors to navigate. The diagram highlights the three main sections of the website which display relevant information for the three actors: customers, cleaners, and administrators. The diagram was heavily used to inform the development of the wireframe. The UML state machine diagram shown here reflects the event-oriented dynamic behavior of actors through finite state transitions while using the Omniclean service. The state machine diagram is vital for understanding actors' behavior within a system, particularly complex ones, and this is distinct from the activity diagram. The state machine diagram is a representation of states and transitions. To clarify on the notation, transitions are marked with an arrow, while states by rectangles. Initial and final states are represented by a circle. Transition occurs when an event occurs and an action is taken. Shown here is the state machine diagram illustrating the transition through a number of states, such as creating an account, logging in, submitting feedback, and so on. The proposed system architecture design for Omniclean deployment is based on a three-tier architecture. The system consists of many interlinked modules that carry out specific functions and together allow the user to interact with the system. Here the user interacts with the front end, which renders a visual interface to the user. This facilitates interaction with the system, with the server acting as a mediator between the user and the database. Requests made by the user are received by the server, which queries the database as per the requests, with the returned data generating new server pages dynamically. The mockup is the culmination of the aforementioned stages and reflects a user-friendly interface for customers, cleaners, and administrators. This reflects the realization of Omniclean's key requirements. Users without an account can click Create Account and are redirected to the Create Account page where they can enter their details before submitting the form, which sends the user's data to the database and creates a new user. New users are then redirected to the login page where they can enter their username and password. Upon successful completion and submission of the form, a notification displays and the user is successfully logged in. The first menu option in the customer account is the profile page where they can update their profile information. If any details of the account are updated, a pop-up notification displays. The prices page provides customers an indication of the minimum prices they can expect to pay to use the service, though this can vary based on the frequency, duration, and range of cleaning services required. On the cleaners and services page, customers can view a video which demonstrates how the Omniclean service works, with key information being shown in a flow diagram style. Here, a user has entered their postcode and is able to view key information about local cleaners, the services offered, and average rating. Upon selecting a cleaner, a customer can list the services they require, list other information such as the frequency and duration of cleaning services they require, and whether they provide their own cleaning equipment. Upon clicking Book Cleaner, the customer is redirected to the Confirm Booking and Pay page, where customers are able to select their chosen payment method before entering relevant account details and clicking Confirm. A notification displays to let the user know that they have almost completed the booking. In the Cleaner portal, a cleaner receives a job request which can be viewed alongside key details about the customer. The cleaner can confirm or decline the booking, which will send the customer an email notification regarding the outcome. Back to the customer profile, there is also a review section where customers can read reviews and submit their own feedback once they have used the Omniclean service and paid. Cleaner and administrator pages are created by administrators only, and they are able to log in using the same page as customers. On the administrator portal, there are a range of sections which are necessary for the overall operation and maintenance of the Omniclean service. On reflection of our group work, some of the successes include maintaining a continuous client focus, delivering the project in a timely manner, and applying agile development using Scrum methodology. Potential areas for improvement include the amount of time spent working on iterating, the initial lack of familiarity with UML notation among the team, and tasks often being completed to a level greater than required. Overall, the project is seen as a great success, with client expectations being met and exceeded, with feedback being incorporated throughout various iterations. Going forwards, the requirement for on-demand services is definitely on the increase, and the development of the Omniclean empire is definitely a potential on the horizon.